Okay, hi everyone. This is Ayush from the ecosystem team at Vana. We also have Brennan from our team who will be taking the session over. Over to you, Brennan.
Welcome everyone from sunny Berlin. Today we will be doing the workshop for building your first DataDAO. Very exciting. I hope everyone's as excited as I am. Here's just a recap of the overall agenda for everyone if you need a reminder of the next meetings as well. My name is Brennan Nunamaker. I am a senior software engineer at Open Data Labs in Vana and currently the developer experience lead. So today, what will we be talking about? First, we will discuss or reiterate what is a DataDAO, because these concepts, they get thrown around a lot. Sometimes it's easy to kind of lose track of what this concept actually represents as a DataDAO. Then we will have our actual workshop where I will build a DataDAO and you guys can follow along and also build a proof of concept DataDAO. And then we can discuss next steps, where to go from there, and what resources exist and where you can get help as well if you need it. So to start off, what is a DataDAO? So conceptually, it's a community-owned data pool where you aggregate a bunch of data points from individuals, and these data points in aggregate can then be valued through Web3 tokenomics, in our case, VRC20 tokens. A DataDAO also has a governance layer because it is still a DAO. It's still a decentralized autonomous organization, right? So that's baked into it. And it also has built-in data contribution safeguards. So the main one for that is like the proof of contribution that each DataDAO implements for themselves, and essentially provides a mechanism for evaluating every single individual data point that was contributed to the DAO. And later we can use that for things like paying out to DAO members, etc. What this means under the hood, like from a technical perspective, is that DataDAO is basically just all of these things. It's the DLP smart contracts, so the data liquidity pool smart contracts, where users can contribute data, where money flows into the DLP. And we also have VRC20 token smart contracts. So these are like the data access tokens that a DLP can have, where it allows the market to kind of value the data that's stored in the DLP automatically, ideally. And we also have proof of contribution images. So these are the Docker images that are used to basically evaluate the quality, the authenticity, etc., of the individual data points. We have a data contribution UI where data contributors can use this as an entry point to upload their data to the DataDAO. We also have data refiner images, which are also Docker images that structure the data that was uploaded to a structured format where data buyers can later query the data more easily than if it's just like an unstructured JSON file or something. So that's the purpose of the refiners. And DataDAOs can also define on-chain data access policies, meaning DataDAOs have fine-grained control over who can access which data at what cost. And this is very fine-grained, so you can even do it on the individual column level or field level, if you will. You can do it on like the table level, or just grant generic permissions, for example. So this is already a lot. It can be a little overwhelming at times. Just take it step by step, and we'll build the DataDAO. I'm trying to go slow for everyone so that everyone can follow along. If I am going too fast, please let me know. Right, but before we start this build along, there is one thing I would like to highlight as a builder in this ecosystem, especially for the non-Web3 folks that maybe only are more familiar with Web2 tech. But basically, we have this page in our docs now, which is a single source of truth for smart contract addresses. I would recommend to everyone to take a look at this page, probably bookmark it, because it provides super fast access to all of the smart contracts that you interact with. For example, the DLP registry. It links directly to the Vana scan URL, so you can look at the contract, you can look at all of the transactions, you can go into the contract, you can look at the code of how things work. So if you're encountering a specific error, for example, like invalid DLP status, it's usually a pretty good way to figure out why this is being caused if you just look directly at the smart contract code. Even if you don't write any like Solidity code, I think this is a very good strategy to kind of understand what's actually happening for yourself. And if you open like a support ticket with us, we can help you better the more context you give us. So you can look at the code here. You can see here this error is being thrown because the status is invalid or whatever. I won't go into too many details here, but you can look at the code. You can download the ABIs for your local development if you're using something like WAGME in your code base, which we often do in our templates as well. And you can also interact and explore directly like which functions these smart contracts have. So, for example, you can just go in and kind of query DLPs that are already on the network. You can see all of the data. You can kind of explore. And I would really encourage everyone here to kind of engage with these smart contracts because it is just really helpful for interacting with the system. It serves as like a central UI where you're interacting on the protocol level, as opposed to going through multiple services where you might not be sure exactly where the error is happening. Here you can look directly at like the on-chain state. And you can't only read, you can also write. So if you want to manually do stuff like register a DLP or deregister a DLP, this is the place you do it. You just connect your wallet and there you go. So that's just to start. Now for the actual build along. The prerequisites were posted yesterday, I believe. I realized that the OAuth might not be sufficient. So I will just show everyone here, if you have already tried setting up some GCP credentials, OAuth credentials for this demo, this is kind of what it should look like. So it should actually be for the localhost port 3000. I don't think this is documented anywhere, so I'll just drop it into the chat. And we also need authorized redirect URLs for the OAuth. This is just so that the demo application and the demo DataDAO that we're building, including the contribution UI at the end, which leverages OAuth, works. So I would encourage everyone who wants to follow along to set this up. You basically just need to go search for the OAuth credentials and create a new client ID with the JavaScript origin from localhost and the redirect URS. Okay. So if anyone still needs to do this, now is a good time. The other kind of non-technical prerequisite that we have is Pinata. I would also like to highlight here that you can register on Pinata for free. That should be sufficient for the demo. When you are creating your API key for the test, what is important is that because Pinata recently updated their API endpoints, that all of these legacy endpoints are activated. Otherwise, we'll run into downstream errors during the demo process. But I think that means we can jump in. And I've already set up a directory. This can be anywhere on your machine. It doesn't need to be in a specific folder or anything. But let's get started. So you can run the demo create-data.dao tool basically like this. And this is still in a very early version. So kind of see this as an alpha where the happy path should definitely work. But if something breaks along the way, we might need to refer to docs or fix something. Don't be afraid of reaching out on the Discord. We're always happy to help with things like this. But the CLI tool that we are using is called create-data.dao. You can run it with npx. And the command is basically create, and then your data.dao name. So this is not going to be the name that's registered on chain. It will only be the basically directory name for the data.dao project that's created as sort of a monorepo. But it helps to make this something unique. So for example, I'll just do this, and then we can start the tool. It goes in, checks the prerequisites, provides some links for installation guides if you need them, and we will go with the quick setup. I think it might take a little longer than 10 minutes in this case, but let's get started. So once we start this out, it generates a wallet for us with an address and a private key. Don't share this private key for the Web2 folks. This basically gives anyone access to the DLP wallet that we've just generated. Okay, so usually what you would do is go in, copy this, paste it somewhere. You will find it again. It can be a 1Password or something else. And then it's already asking us for our API keys, which I will just paste in here. Okay, so it has our Pinata credentials. Now it's asking for our Google OAuth credentials, which in this case is the client ID. We can take from the Google platform website console, Google console website. We can take the secret and paste it in. And then it asks us for our GitHub username for later when we are forking repositories and things like that. So after I confirm, it basically goes through all of the different values that we can configure, like the data.dao name, the token name, the token symbol, etc. It's pre-filled with these defaults generated from this kind of project name we used at the beginning. But so ideally, you can just confirm, and it performs a check on the data.dao name, because if this isn't unique, then a later step will fail. So just make sure if this uniqueness check does fail for you, you can just restart the tool with a different name. Nothing has been created yet, and it should be fine. I will give you guys just a second to kind of catch up to this if you need it before I continue. If there are any questions, you can drop them in the chat as well. So we have our data.dao name confirmed, our suggested token name, which we can also confirm, the token symbol, which doesn't need to be unique because this will be salted later, but the symbol won't be. And then it starts generating the project. So what you can see now is it has created a directory named with the project name that I specified initially. There are contracts, proof, refiner, UI, and a deployment.json. This is mostly a monorepo structure. So these individual pieces, you might notice some of them still have like a GitHub workflow or something. these are just forked from all of our template repositories, which I will also show you later in the slides with the links, so you can kind of investigate yourself if you want. This deployment JSON, it does contain some sensitive information, so you probably don't want to commit it to a repository or anything. Just be aware of that. I can now explain the different folders that we have. So for the contracts, you'll remember we have the DLP smart contracts and the token smart contracts. If you open this up a little bit, it has mostly everything, but I think the relevant ones are DLP and that for the token, that DAT stands for data access token. So just an aside, it's not too important. You don't actually need to look inside of these right now, but I would also encourage everyone to explore a little bit. Also for the proof, that's the proof of contribution. And if you look in here, you can kind of see how this default template proof is implemented. So we are scoring all of these values: quality, authenticity, uniqueness, and ownership, the values that you've learned about in previous sessions at the Vana Academy. And there's also the refiner, which structures unstructured data. So if you have like a JSON file or some other format, the refiner basically converts that into an SQLite database for containing a single data point that can then be aggregated later for querying. The UI is just a typical React project, Next.js project, I think, with TypeScript. And all of these generally have local commands as well, so you can play around with that if you want, but we can just continue with the demo for now. This is now asking us, because we need to do some stuff in GitHub, like add some commits and things like that, it's asking us how to set this up, how to set up these new repositories that we need. I don't have the GitHub CLI installed. Some of you might. I will continue here with the manual setup just for demonstration purposes. There are two repositories that it will now try to create for us. The first is the proof of contribution repository. So if you open up that link, it should pre-fill everything. It has selected my own GitHub username as the owners. You can change that to an organization if you need to. You can adapt the repository name and the description or whatever. It should remain public, just for verification and deployment purposes later. You'll see what I mean in a second. So we are first creating our own proof of contribution repository, and then we can go. So this is also a nice note. Sometimes actions may not be enabled. Here you can see for me they are. If they aren't, just enable them, and then this initial workflow should run. Doesn't matter too much yet. And then we can also create our data refiner repository. So if we click on that link, it does the same thing. It pre-selects the correct template. You can update the name, the owner, etc. You can then create the repository. And it takes a little moment. Now it's created, it's forked. And then we need to enter the URLs. So for me, it has also pre-filled this. If you've changed the name, you'll need to change it here as well. But I can just confirm with enter. And for my refiner as well, I can just confirm with enter. And then it starts installing some dependencies. This can take a little moment. We just have to wait. Okay, so it looks like all of the dependencies were generated correctly. You can see it installed some stuff with Node as well. And now we need Vana tokens to deploy our smart contracts that have been generated in this directory. So this is my wallet address that was generated earlier. I can copy it again and go to the faucet. If anyone has any issues with the faucet, you can just drop a message in the chat and I can send you some from my test wallet. But when you open the faucet, you just paste in your wallet address. I don't think this is mandatory anymore, but you can click on it to be safe. And then you can click get 10 Vana. I think I used this already, so this probably won't work for me, but I will just send it manually. And then you need to wait a moment for the transaction to confirm. And if you want to check the balance of your wallet, you can just go to moksha.banascan.io, paste in your wallet address that was created, and then you should see a balance. So the faucet actually worked for me, but I sent 3 more. All good. I can close that out and return to the tool. I funded my wallet. Now we can deploy our smart contracts. This will also take a few minutes. It's a little bit of a slow process because we need to compile everything, deploy, and then verify it. So it's also multiple contracts. It's not only one. There's a question, how do we get tokens? Do we need to pay for these and how does that work? With the faucet that I showed, it will be free. On testnet, it doesn't really matter anyways. But for mainnet, there used to be a DLP registration fee that was very recently reduced to 0. So you should only need tokens for gas, essentially, when registering your DLP. And I can drop the faucet link here as well. Yes, thank you, Ayush. Maybe in the meantime, I can show you. All right, I can't show you it. So this tool also generates a lot of output. We are working on improving this because it's still in this alpha stage. But if you read, you should be able to find most of the information. You can see like which steps are being run. Like first we configure the DataDAO. Then we deploy the smart contracts after creating the project. Yeah. The wallet should be created by this tool. There was a question about it. In the very beginning of when we started running this command, it generated a wallet for us. So this would actually be the wallet address that you need to fund because that's the wallet address that owns your DataDAO and owns the smart contracts and all of that. But again, don't expose this private key. Here it's fine because it's a demo on testnet, but on mainnet, anyone who has that can steal your tokens. We can see the deployment process and progress. It basically summarized everything here and registered the DLP on chain, which means we can now also go in to Vanascan, to the block explorer. And there is my DLP contract that was deployed. We can see in the transactions, there was a creation transaction and all of these functions that you would usually use. So for example, there aren't any contributors yet, so this value returns 0, which makes sense. But this is just another example of what you can do through the block explorer. And now it is asking us to register the DataDAO. It checks the balance. This is outdated. Now the balance is 0, so we don't need to pay this registration fee of 1 Vana. On testnet, we can just register. It submits a transaction, which we can also go to the block explorer to see what exactly it's doing. So So if we look at the details, we can see it has all of our DataDAO information for the registration info. You can see what the different parameters are typed to, and it was successful. Okay, so now it has prepared the proof of contribution for deployment. We can say we want to deploy automatically. That's what I'll do here. And now it says successfully pushed. The proof is being built. It takes 2 to 3 minutes. So we need to wait for the new build to complete. It also has the link we need to visit to basically look at the releases. This is from 8 minutes ago when we initialized the project. So if we go to the actions, we will see what it actually did. It updated the DLP ID that was registered on chain inside of our repository that was created. And this will generate a new release that we can then register on chain. Remember, the proof of contribution is a Docker image that we later use to run on every single file contribution to evaluate it. For the refiner, it's a similar thing where it's a Docker container that runs on every single data point to structure it so it can be ingested for data access later. Okay, I think this takes about a minute. So it's already finished, which means we can go to the releases. A new release was generated. And this is the image asset where we can copy the link address. And what this does is this link is then registered on chain, and it later allows the services to download the image and run it. So we need to enter the URL here so that it can register it on chain for us. This is the URL that I just copied. And everything worked. So now it's going into actually working on the data refiner. It's generating the schema for our structured data. So what that means is what fields does our structured data have at the end coming from an unstructured format such as JSON. So we can also push this automatically with our tool. It's a similar process where we also need to go to our project, look at the releases. I think here it doesn't matter as much because there was nothing to pull. So this commit doesn't really change anything. We can use the release that's already there. We can say, yes, there is a successful build available. We can paste in the link here. The schema was uploaded to IPFS, so decentralized storage in our Pinata account. This is also so that the schema file can later be downloaded from the on-chain record. But we can just enter our URL in here, and it's waiting for a transaction confirmation to register our data refiner on-chain. It should be okay to post errors here because this is all on testnet. So there's no real token value that can be lost. Okay, and after this last step, it configured our UI environment, which is here. And now is probably the most interesting part. So there's a summary of the DataDAO that was created, the DLP ID, the refiner ID. We should store this information for later, just so that we have it. We know which DLP we are on chain, etc., where our refiner is located. So now what we can do is go into the project, go into the UI subproject, and then we can run npm install, which just installs the project dependencies. You can ignore most of this output, and then we can run the project. So npm run dev. This has started a local development server. So if we go to that URL, you can see it's actually a local project. And this is why we needed to register localhost with port 3000 in our OAuth credentials so that this UI can authorize. So I will now contribute some data. I can sign in with Google. I'll have to select my account. We can allow this. It basically just downloads all of this like contribution data. So the profile, the email, the locale, the drive storage. This will only be in your own DLP. So you can contribute. And I have MetaMask with a different wallet that I've already set up earlier. So I can just confirm here. And my data will be contributed to my DataDAO. It asks me for a few confirmations in my wallet for transactions that it's doing in the background, like recording the encrypted data on the network. This takes a little bit of time, but all of this will be visible through the Block Explorer as well. You can just confirm these. So first it encrypts the data and uploads it. Then it registers the encrypted data on the Vana network. This is usually just an IPFS URL in Pinata or something like that. And then we are requesting validation. After that, the proof of contribution will be run. We'll get an attestation, and then the reward will be paid out to me as a contributor going through this process. There's a question, how does the refiner automatically deploy? Does it need a command to run? That's a good question. So let me see if I can show you what actually happened on chain after I finish this. For that, we will need our refiner ID, just so I can show you. And contribution was successful and the reward has been claimed. So we can even look at the reward transaction. Sorry for that. We can see there was a file ID that was rewarded with a proof index. So a proof that was generated for that file was rewarded to my personal wallet separate from the DataDAO wallet that was created. Okay. Regarding the question for the refiners, let me just get the, so if we go back to the smart contracts, there is a data refiner registry contract. And this is also why I encourage you to explore here a little bit so you become more familiar with what exists. And we can see 5 minutes ago, there was an add refiner method smart contract call on this data refiner registry smart contract, where it passes in which DLP it was, what the name of the refiner is, where the schema that it generated is hosted. So this is in Pinata and IPFS. That's why we needed to create that account. And it's just a demo SQLite schema for the structured data that we are generating. And we also have the refinement instruction URL that was also configured by us pasting in this URL. So the tool basically took all of these values, aggregated them, and then called this add refiner method on chain to store the refiner on chain. Does that make sense? Okay, I will assume so. Thank you. Great. Are there any other questions about this process itself? If you got stuck or something, we can take it to the Builder Discord after this, because we are somewhat limited on time to help each person individually. but feel free to just ping in the tech questions in the Builder Garden. You can ping me directly, Brennan, and org. You should see a few messages from me, so we can do that. Okay. In that case, sorry, 1 second. I need to find my slides. Yeah, okay. So we have now completed the build along. What are the next steps? If you want to continue building your own DataDAO, of course, then you need to customize the proof of contribution image for wherever you're pulling the data from. So it can be any platform, I don't know, X or GitHub data, or wherever you're getting your data from data contributors. You need to customize your proof of contribution image. What that means in practice is you would go into your proof of contribution repository that was created and basically update the logic in this file mainly, but it's your own project, so you can do whatever you want. You can also customize the data refiner image because the type of data that you will be processing in your DataDAO will be different. You will need to structure it differently than the demo data, which was only like Google Cloud Storage data. Meaning if you are processing, I don't know, GitHub data in your DataDAO, you would need to structure that also in your refiner project. All of these projects also have READMEs that should help you get started. But if you get stuck, also feel free to reach out in the Discord. For the refiner, you would just go in and generally customize this refine.py and kind of mold whatever input data you have into your structured data format, which is the schema that was also registered on chain with this. Okay, you would also customize the UI for data contributors, and to make sure that they can access the data and buy your data, you would want to configure data access policies. I don't think I've covered this yet, but that is through the query engine smart contract. It should be this, where you can see here as well, there are a bunch of contract calls with add permission. That is generally the function that you would want to call. With this, you can grant permissions to a specific wallet address. So if there's like somebody that wants to run data through your DataDAO, you would use their wallet address here, and you can grant them table level or column level permissions and set a price. But you can also configure generic permissions that apply to everyone. It's the same concept. So if you don't set a column name or a table name here, it will basically be they have permissions at this price for the whole data set schema. And you can restrict it to individual tables or columns. But you also need to use your refiner ID as a reference. This is what was output by the tool. So you would want to configure those before you really go live on mainnet. Okay, so there are some questions I will try to address first. Yes, there is a step-by-step. So locally, if you just want to deploy your DataDAO and then iterate, you can use this tool on testnet. Or if you want to do it manually, there is a docs page or just give me 1 second. Okay, here is the link. If you want to do these things individually, but this should provide a good starting point where you can build confidence as you go. And Another question is, can you redefine a smart contract and how it is used? So a smart contract is basically a primitive of the EVM compatible layer 1 of the Vana network. So maybe that was too many Web3 terms, but the smart contract is basically just a collection of functions, and it has its own internal storage that grows with every block that's mined. So, for example, we have a data registry contract. This is where the files are uploaded. This is where the refinements that the refiner generates are uploaded. So we have the unstructured data, which is encrypted as the file. We have the structured data as the refined file. But when you call one of these functions like add file to the data registry, then what it does is it stores all of this data internally in the memory of the smart contract, if that makes sense. Okay, there are 2 more questions. Pinata is just an IPFS provider. IPFS is basically decentralized storage. So it's also a protocol-based solution where you can even access files through different gateways. So once a file has been uploaded to IPFS, it generally stays there. You can control how easy it is to find, for example, or access through what is called pinning or unpinning. That is what you would do for like a data deletion request in your DataDAO. You would find the file for a given user and then unpin it from IPFS. And we would, there's a way to delete this data also internally that was indexed and aggregated. So IPFS is just a decentralized storage solution, and Pinata is just a provider for IPFS that allows you to configure your own gateways for downloading these files, where only files that you pin can be accessed through the gateway. Yeah, you should be able to use any IPFS provider. I think we just recommend Pinata because it gives you that extra control. And is it possible to store data in different languages? Yeah, so the protocol doesn't have an opinion on like the language that it's stored in. Ultimately, the network just views it as another file. So you could have one file that's in English, one file that's in French, or something like that. Or and these individual data points would then be refined. Or it could even be the result of a refinement if you have like English files and you want to refine all of them into a different language. I think it's possible. I'm not exactly sure why you would do that yet, but like it can basically store any files. It doesn't really matter what the languages are in that case. So you should be good for that. And yeah, we can go through all of the build steps that we went through as well, just to kind of summarize what the tool was doing in the background. It's hard, but let's see where we started. Okay, it's a lot of output, as I said. So the first step, right? We said we wanted quick setup. Basically, we check the DataDAO name is available. We need a wallet that the DataDAO is owned by. Generally, you want like a separate wallet for this, not something that you're using in day-to-day transactions, simply because if your wallet gets compromised, they would, or if the DLP wallet gets compromised, all of the data that you have aggregated is then also compromised. So it's important to keep this kind of very secure and separate from something you would use for day-to-day investing or something like that. you need some IPFS storage provider. In this case, for the demo, we only needed Google OAuth for the actual data contribution at the end. So for example, if you had a different contribution flow or different data provider, you might need credentials from them, you might not. But in this case, for the demo where we're contributing our Google Cloud Storage data, you definitely need this Google OAuth. But in your individual cases, you wouldn't. And these are all separate repositories. We haven't gotten to that in the slides, but we will soon. We're also reaching the end here, so I'll try to go quickly through this. It clones all of the repositories that I will link. It stores a bunch of configuration information that is then disseminated through all of the various projects as they are needed. So for example, the UI needs the Google OAuth stuff and the IPFS stuff, so it knows where to upload the files. It needs to know where the refinement will be run, so the refinement service and all of that. But it kind of disseminates all of these values in the background. If you look at the individual projects, try to look at like the .env, .example stuff. You can also look in the READMEs. It should tell you where to configure what. If something is missing, please flag it in the Discord and we can fix it as soon as possible. Okay, so going back to this. After we've checked our name and everything, then we needed to create our proof of contribution repository and our data refiner repository through these Vana templates that are publicly available. The links are also in the resources slides. But you basically just need to generate a new repository out of them, and then you can customize for your use case. It then requires funding to deploy the smart contracts. There's a script that does this. I think it should be documented how to do this in the docs as well. If you can't find it, please ping us. We'll help you out. And okay, that's just a summary of everything Hardhat did to deploy it automatically in the background. And then it mints a bunch of DLP tokens and adds some rewards. But this should all be documented in the advanced guide. It then deploys the smart contracts. So the data access token and the DLP smart contracts. Once that's done, we continue with actually registering the DataDAO on chain. This is in the DLP registry contract. There should be a register DLP method, if I'm not confused. And this tool can do it automatically. You would just go through the block explorer. There is no more minimum requirement for registration. And once it's registered, then we deploy the proof of contribution to the on-chain smart contracts. Then we deploy the data refiner to the data refiner registry smart contract. Then we upload our refiner schema to IPFS and register the refiner on-chain. Then we need to update our UI configuration with like the refiner URL and everything like that, and then it should work. So it's a long process. There are a lot of moving parts. Please look at the docs. Try to understand with this tool what it did in the background, what you can kind of play around with to get a better feeling for all of these different moving parts. And you can always ask us for help if you get stuck somewhere. Okay. And these are the resources. So the Discord, I think everybody here is in the Vana builders. We also have the docs. We're working very actively on these docs, so they should be improving rapidly as well. But if you notice something or that doesn't align, reach out to us, we'll fix it. I sound like a broken record at this point, but that's the only way we can improve, right? So there is a single smart contracts repository, Vana.com, Vana smart contracts. There is a proof of contribution template for the demo, which is DLP proof template. There is a template that is more production ready that you should use when actually migrating to production. The demo stuff might have a lot of noise around the Google specific logic, which won't apply to you. There's also a data refiner template repository that you can use. It should be fairly simple to customize. And there's a UI template, which you probably won't want to reuse for your project, for your DataDAO, but it might be a good reference. And yes, thanks everyone. If there are any more questions, now is the time. There is a question about if your wallet is compromised, your data is compromised. Yes. In Web3, that is generally how things go, like ownership, because it's so decentralized and we don't have KYC, like know your customer logic, where we're validating people's passports or something. Authentication is generally handled through the wallet address, and the smart contracts track ownership by the DLP owner's wallet address. So like it doesn't make sense if someone with a different wallet address uploads a refiner and then tries to run it with your DLP, right? You don't want that because you want to be the one structuring the data as opposed to some random third-party person that might be abusing it somehow. If you want to safeguard your wallet once it's created, there are different ways to do that. I think one way is to basically print it onto a piece of metal and don't like expose it to 1Password or anything. Yeah, I hope that helps. And if there are no other questions, thanks everyone for your time. I appreciate you taking time out of your day to come build the DataDAO. This is only the first step, so please don't hesitate to ask on the Discord. And see you in the next session.
Yeah, thanks everyone. Thanks for the session. See you.